today's lesson because we are going to balance liquids on top of each other in a density tower. Okay, it's gonna be really, really fun. I do encourage you guys to maybe get a parent's help because this experiment will require steady hands. Anyone can do this experiment at any ages, but parents might have steadier hands when it comes to pouring liquids on top of each other because one little mess up might mess up your tower and it might mix things up, which is not what we want. But anyway, you can still do it without a parent if your parents let you. For this experiment, I'm going to be using a mason jar. You can use pretty much any glass or cup that you have in your house. I would suggest that you use a cup with sides that are the same circumference apart, the same width apart as they are at the bottom and at the top. A lot of cups and glasses, they'll get wider the taller they go, and that's not going to help you because that means you might need some more liquids, for the liquids that we're using on top, and also that might mess up your tower some because more liquids might make it heavier and it'll just mess up things up. So I would suggest using something that has straight sides, same width at the top as it is the bottom. For the liquids that we're going to be using for our density tower, it is something that most people should be able to find in their own kitchens. If not, you can easily get these at the store. Just normal dish soap. We're using honey, vegetable oil, or any kind of oil really, milk, and water. So those are the only ingredients you need. I'm also going to encourage you guys at the end to find things to put into your density tower and see how far down they sink or how high they float up, because we're going to talk about that here in a few minutes. But before we get to our experiment, let's talk about density, let's talk about volume, let's talk about weight and mass and what these terms are, because you hear these terms a lot in science: density, weight, mass, volume. These are always used in science. First, I have a question for you guys. Which do you think is heavier? 1 kilogram of gold or 1 kilogram of feathers? They're two different objects. Let me say that again. Which is heavier? 1 kilogram of gold or 1 kilogram of feathers? Technically, they're going to be the same weight because they're both 1 kilogram. Okay? However, let's think about how many feathers it would take to weigh 1 kilogram. For gold is naturally a very heavy substance. It's a very heavy object. So you're only going to need a little bit of the gold for it to get 1 kilogram. Feathers, though, are incredibly light, and so you're going to need twice, 3 times, even maybe 4 times as many feathers as you would gold in order to get the same weight, because feathers weigh less. Okay? Here's another question. If you have 2 boxes the same size and one box is filled with gold and one with feathers, which would be heavier? We already know that 1 kilogram of gold and 1 kilogram of feathers weigh the same, but if we have a box of gold here and a box of feathers here, which is heavier? The gold. Well, why? Because once again, gold is heavy, and so you don't need a lot of gold for it to already outweigh a super, super light feather. So when you have a box of gold, that's going to be crazy heavy, whereas feathers, because they're already so light, even filling them to the top of the box, they're going to weigh less than the gold. Make sense? Okay, so this is why density matters. Okay, and it's because we're talking about flotation. Let's say you're swimming in a lake. It's summertime. It's not summertime now, but let's say it's summertime, and you need a flotation device. You're not going to choose a golden flotation device. You're going to choose a feather flotation device. Why? Because feathers are lighter. Feathers are less dense than gold, which means feathers are going to float on top of the water and going to keep you on top of the water, but gold is going to sink because it's heavier and more dense than water, and it's going to cause you to sink to the bottom. So I'm using the word dense a lot. What is density? Okay, density is basically all the molecules in an object divided by the amount, the closeness of how tightly packed those atoms are. That's a lot of science words, okay? But I'm gonna say it again. Density is the amount of molecules in an object. So let's say the amount of molecules in this glass here, okay? We'll use my travel cup here. The amount of molecules in this travel cup, I lied again. We're gonna use dish soap. So density is the amount of molecules that are in this dish soap divided by how tightly packed those atoms are, okay? In other words, we have to know what volume and we have to know what mass is. Volume is the amount of space that something takes up. Like this picture of a cat in a bowl, okay? We all heard the phrase, cats are liquid, and that's because they can bend their bodies to fit tightly packed into a bowl, into a clear space, okay? Volume is how much space an object takes. So volume, so if we can use math and we can see how much volume this dish soap takes up, okay? It is how much space in this small container that the dish soap takes up. Same thing with our honey and with vegetable oil and milk and water. How much does that liquid take up in our jar? If you're drinking Coke and you have a Coke can, how much Coke is in that can? That is the amount of volume that you want to know, okay? It is, so, and then we have mass. Mass is how heavy something is. It's not weight. Weight is actually a force. So for instance, an object here on Earth is going to weigh more than it does on the moon, because weight, how much something weighs is determined by the gravity. On this Earth, I am so many pounds. I weigh a certain amount of pounds on this Earth because the amount of gravity that is on me. If I were to go to the moon, I would weigh less because there is less gravity pushing me down to the moon. For something to be for something to have mass, it is going to be just as heavy as it is here on Earth as it is on the moon, because it has to do with the amount of molecules that are in that object. So for instance, a brick. Let's say I'm holding a brick. Or no, let's go back to our gold. Let's say I'm holding a box of gold, or just one little brick of gold. Okay, that brick of gold is going to take up the same amount of space. It's going to have the same mass, the same heaviness on Earth as it does on the moon, because the amount of molecules inside that gold doesn't change. The gravity pushing down that gold changes. So if I were to go to the moon, I could probably pick up a box of gold super easy because there's not as much gravity pushing the gold down to the ground. But the amount of mass, meaning the amount of molecules that are in that gold, stays the same. So technically it is just as heavy as it is here on Earth as it is on the moon. So when we go back to the word density, density is the heaviness of the object divided by how much space that object takes up. Like I said before, it is the molecules in the object, or the mass of it, divided by the tightness of the atoms, or how much space that object takes up. So it is the heaviness or the mass of it divided by how much space the objects take up, okay? So does this make a little bit of sense? Great. So density is connected very closely to buoyancy and to floating. Why? Well, because we already know that density is the heaviness or the mass of an object divided by how tightly those atoms are packed together, or the volume of the object. So let's say we have brick and styrofoam together. We know what brick is, we know what styrofoam is. The brick is more dense than styrofoam. What do I mean? Well, bricks are heavier because they have more molecules in bricks. Also because it's a solid object, and because of the object, the atoms are more tightly packed together. So it is more dense. Styrofoam over here though, it has less molecules, and the atoms are not as tightly packed together. There's more air in between the molecules, which means if brick and styrofoam were in a liquid form, styrofoam would float on top of brick. Okay, so let's put this in terms of liquid. In our experiment, honey is going to go on the bottom of our density tower. Why? Well, because honey has more molecules in it, and the atoms in honey are more tightly packed together. Whereas we have oil is actually going to go close to the top of our object, and that's because oil has less molecules and the atoms are not as tightly packed together. So if we were to stack honey and oil on top of each other, oil is going to float on top of honey. And actually, as I'm holding them here, I can already tell that the weight of honey, it feels heavier than the weight of oil, which is really cool because I can feel that honey is denser. Honey has more molecules and the atoms are more tightly packed together, and I can feel that than oil. So oil is going to float and it's going to sit on top of honey. Make sense a little bit more? Okay. So if we were to go back to, so this is the same thing as we were to go back to with brick and styrofoam, and let's say you're swimming in the lake in the summertime, you don't want brick to hold you up above the water because there's more molecules in brick and the atoms are more closely packed together in bricks, which means that bricks than there is in water. And so bricks are going to sink underneath the water because there's more molecules and the atoms are more tightly packed together. Whereas you want a life jacket that's full of styrofoam because there's not as many molecules in styrofoam and the atoms are not as tightly packed together as it is in water, which means styrofoam is going to float on top of water, which means it's going to keep you on top of the water. Make sense? Okay, so let's go on to our experiment, okay? So, I have my glass. I'm gonna keep this on paper plate because just in case, I don't think this is gonna go over the top, but this is just in case. I don't really feel like making a mess today. But if your parents say make a mess, go for it, make that mess. Okay, so like I said before, we're going to have honey as our first object. It is the densest of all liquids we have here. Once again, it has more molecules and the atoms are more tightly packed together. So I'm going to pour honey to the very bottom. This might take a few minutes and I may have needed to put a little bit more honey. There it goes. I'm not putting a lot of liquid in here. Obviously the amount of liquid you put in your jar can be determined by however much of liquids you have in your house and how much liquids your parents let you put into your experiment. So we have honey. So that's done. We also have oil, dish soap, milk, and water. So which of these objects do you think is going to go on top of honey? Oil, dish soap, milk, or water? If your answer is milk, you are correct. Why? Because with honey, there's actually a lot of ingredients put into honey. You have sugar, which is really heavy. You have, well, actually, it is water, and it's also mostly sugar is what's in honey, which are both very heavy objects. Milk also has sugar in it. It also has a little bit of oil in it, and it also has some proteins and some water in it. So it's not quite as heavy as honey, but it's just enough to be on top of honey. So when I do this, I'm going to pour it very, 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 very slowly. Maybe let it try to slide down the side like this. You want to try to refrain from just dumping them all on top, because if you do it slowly, that will hopefully keep your liquids from mixing. Now, I am using 1% milk in this. You can try it with different kinds of milk. Because the different types of milk, so you have 2% milk, you have skim milk, you have 1% milk, you have whole milk, you can try almond milk, you can try oat milk. I want to encourage you guys to try with different kinds of milk and see if all of them will float on top of honey, or maybe if some of them are denser than others. I think all the different types of milk are going to float on top of honey, but let's see how they will hold up under the dish soap, oil, and water. Because I haven't actually tried with other milks, but I'm using 1% milk here. So our next layer, let's see here, our next layer is going to be oil, dish soap, or water. Which one? Water, actually. You can always color this with food coloring. Actually, nope, I lied. It's actually dish soap, which I was really confused there for a second, because yeah, it's dish soap. And dish soap is because it has water in it, but also has soap and detergent molecules in it, which makes it heavier than just straight up water, because water has water in it. But it doesn't have as much in here as milk and honey do. So I'm once again gonna slide it. And you can see that it might be, is it mixing a little bit? Nah, maybe a little bit of mixing, but it's perfectly fine still. You can see, as you can see, it's stacked on top of each other there. Next is going to be water because, well, it's just water. That's all that there is just water. You can also color this, so you have a different colors of water so you can see it, but I'm not going to use clear right now. And the reason why water is heavier than oil is because the atoms in water are actually really tightly packed. And that's another reason why humans actually are less dense than water, which is why we can float, is because the atoms in humans are not as tightly packed as atoms are in water, which is kind of crazy to think about it, but it's true. So very, very slowly, you might see some mixing a little bit here as it mixes in. Yeah, mine's mixing a little bit. That's okay. You can see on the side that mine got mixed a little bit here on the side, maybe because it's how I am dividing them up. But also if you look, you can see a little bit of how the soap and the milk are trying to separate right there. You can see they're really trying to separate. They're trying to keep the soap on top. And if I let it sit here for a little bit, it might actually continue separating, but we don't have that kind of time. So, and I don't think you want to sit here and watch soap and milk to separate. It'd be a very boring video. All right, last but not least, we are going to use oil. Actually, I'm going to try turning this so don't mix it. Now, oil and water never, ever, ever mix, and it's a pretty common. So yeah, my tower got mixed a little bit here, but you can see some of the so you can see how the tower. You can see some of the separation of the liquids here. I'll be looking right there is best. Oil and water are very famous to never ever mix. Like they never ever mix, and that's because water is less dense than oil. Doesn't matter what you do to them, they are never, ever, 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 ever going to mix very well together when you just have oil and water. And actually, because oil is so much less dense than the other liquids we have here, if we were to put oil in first, and if we were to do all the other ingredients on top of it, our oil would slowly keep rising to the surface as more ingredients are put in because it is so much less dense than the honey, the milk, the soap, and the water. However, we could not stack our liquids like that because everything would get all mixed up together and we wouldn't have a density tower. Even now, I wasn't as careful as I should have been. But hey, you can see it works a little bit. You can see some of my colors here. You can see some of my liquids here, which is really cool. Now, I don't have the objects with me, but I want to encourage you guys at home to, once you make your density tower, to find different objects and put them in here. I say ping pong balls, dice from board games, different kinds of beads, small objects that you have like that, to put it in here and see how far down they'll float, and or how far down will they sink, or how high up will they float. Because objects, like liquids, some objects are less dense than other objects. For instance, people, we float on top of water because our atoms are not as tightly packed as they are in water. Obviously, that's not the case for right here. But you can see different types of board game dice, different types of beads, ping pong balls, things like that. Because some of your objects will float to the very bottom to the honey. Others will only go partially way, and others will stay on top. And it really depends on how many molecules that object has and how tightly those atoms in those objects are packed together versus how many molecules our liquids in our tower has and how tightly the atoms in these different kinds of liquids are packed together. So density and volume and mass and weight and all these things are super interesting terms to explore in science, and we use them all the time in science and really in everyday things, whether or not we can believe it or not. So I want to encourage you guys to keep exploring, keep learning, keep being curious, and I will see you guys again in the library hopefully soon. Bye everyone.